You ever see one of those headlines about a new study and just think, wait, how did they actually know that? Well, today we are pulling back the curtain on the whole world of research to figure out how a simple question gets turned into a so-called scientific fact. Let's dive in. I mean, we see stuff like this all the time. They're super specific, they sound interesting, and they make a pretty bold claim. And, it sounds believable. Who hasn't put on some music to try and get in the zone? But that number, that 40%, that's a little piece of magic that makes it feel legit. So that's the real question, isn't it? How does a general idea, like music helps you focus, get transformed into a hard number like 40%? Well, I'll tell you, it is not magic. It's a process. And we're going to break that whole process down step by step. All right, the very first thing any researcher has to do is get super, super specific. Before you can even think about measuring anything, you've got to define exactly what you're looking for. It's all about nailing down a clear cause and a clear effect. So, the building blocks for all of this, they're called variables. And it's a really simple idea, actually. Anything that can change or have different values is a variable. Things like your age, your height, or, in our example, the kind of music you're listening to and just how focused you are. Research, at its core, is just trying to understand how these changing things relate to each other. Okay, now these variables, they basically come in two main flavors. First up, we've got the independent variable, or IV for short. This is the one the researcher actually changes or controls. Just think of it as the cause in a cause and effect relationship. It's the ingredient they're intentionally testing. And you guessed it, if the independent variable is the cause, then the dependent variable, or DV, is the effect. This is the outcome. It's what the researcher measures to see if their change, that independent variable, had any impact at all. Its value? Well, it depends on the other variable. Okay, let's connect this back to our classical music example. The independent variable, the cause, is whether or not someone is listening to classical music. The dependent variable, the effect, is their level of focus. The entire point of the study is to see if changing the music causes a change in focus. Make sense, right? All right, so we figured out what we want to measure, but the next big question is, how do you actually do it? This is where the researcher basically becomes a data detective. And like any good detective, they need to choose the right tools for the job. So let's peek inside their toolkit. So the first big fork in the road for our data detective is this. Do you go out and collect brand new data yourself, or do you use data that someone else has already gathered? Primary data is fresh, it's tailored specifically for your study, but man, it can take a lot of time and money. Secondary data, like government census reports, is way faster and cheaper, but it might not be the exact fit for the exact question you're asking. Now, if you decide to collect your own data, what's called primary data, you've got some really cool tools in your belt. You could just observe people, watch and record what they do. You could send out a survey to get a ton of answers really fast. For our music study, an experiment would be absolutely perfect to really nail down that cause and effect link. Or you could do a super deep dive with a case study on just one person to get really rich, detailed info. And here's the really important part. There is no single best method. It's all about trade-offs. An experiment is fantastic for proving cause and effect, but being in a lab can feel a little artificial. Questionnaires are cheap, and they can reach thousands of people, but you can never be totally sure if people are being 100% honest. A good researcher knows which tool is right for which job. Okay, so we know what we're measuring, and we have the tools to do it. But you can't exactly test every single person on the planet, right? So the next absolutely critical step is deciding who you're going to include in your study. And that, my friends, is where sampling comes in. The best way to think about it is like tasting soup. You don't have to drink the entire pot to know what it tastes like, you just need a representative spoonful. The whole goal of sampling is to pick a small group, a sample, that accurately reflects the entire group, the population that you care about. Now, sampling methods are kind of split into two big families. On one hand, you have probability sampling. This is the gold standard. It means every single person in the group has a random chance of being chosen. Because it's random, you can be pretty confident that your results apply to the whole group. On the other hand, you have non-probability sampling, which is usually based on convenience. It's way easier, but you have to be really careful about making big claims about the entire population. Let's walk through a really common probability method. It's called systematic sampling. Imagine you have a list of 1,000 students, and you need a sample of 100. You just divide 1,000 by 100, which gives you 10. That's your interval.
Then you pick a random starting number, say 6, and you pick the sixth person, then the 16th, the 26th, and so on all the way through the list. It's simple, it's random, and it works great.
But wait a minute. What if your population isn't just one uniform thing? What if it has important subgroups, like a university with first years, second years, and so on? Well, with stratified sampling, you divide the population into these groups, or strata, first. Then you take a random sample from inside each group, making sure your final sample has the same proportions as the whole university. It ensures your spoonful of soup has all the right ingredients mixed in. All right, we've covered a lot of ground. The what, the how, and the who. So let's take a step back and see how all these pieces click together to build a really solid research plan. And this is basically it, the research blueprint. It looks simple, right? Just 3 steps. But getting each and every one of these steps right is what separates a trustworthy study from a meaningless one. You have to clearly define your cause and effect, you have to pick the right tool for your specific question, and you have to select a sample that actually represents the group you're studying. A mistake in any one of these steps means that final conclusion, that headline you read, probably isn't reliable. And this really is the heart of the matter. It's not about the flashy headline at the end. The credibility of any piece of research, whether it's our little music example or a massive medical breakthrough, it lives or dies based on the quality of its methods. How the data was collected is absolutely everything. So now you have the tools. You're equipped. The next time you see a study that claims a 40% boost in anything, you can start asking those smart questions. Who exactly did they study? How did they define and measure focus? Was it a proper controlled experiment or just a quick survey? And asking these questions doesn't make you a cynic, it makes you a smarter, more critical consumer of information. And that, right there, is a skill that's more valuable than ever.